In the vast, endless our universe, every single point of light has a story to tell. Over the past few journeys together, we've ventured far, from the icy edges of the Kuiper Belt, to the warm, familiar glow of Alpha Centauri, to the lonely, drifting light of Barnard's star, racing through the night faster than any other. Each of these places, each of these stars, has brought us a little closer to understanding where we come from and how deeply connected we are to the cosmos. Tonight, we turn our eyes to a star that's been with humanity since the very beginning. A star that has guided explorers, inspired ancient civilizations, and lit up our skies with wonder. The brightest star in our night sky. A beacon of myth, science, and endless dream. As we travel farther out into the cosmos, about 8.6 light-years away, near the famous constellation Orion, we find one of the most dazzling sights in our night sky, Sirius, also lovingly called the Dog Star. Sirius is the brightest star we can see from Earth, shining with a brilliance that's hard to ignore. It's twice as massive as our Sun and measures around 1.5 million miles, or roughly 2.4 million kilometers, in diameter. If we could somehow place Sirius next to our Sun, it would outshine it by more than 20 times. Nestled within the Canis Major constellation, Sirius isn't just one star, it's actually a binary system. The name Sirius comes from the Greek word Sirios, meaning glowing or scorching, and it fits perfectly. With a surface temperature close to 18,000 degrees Fahrenheit, Sirius burns with a bluish tint, shining 25 times brighter than the Sun. It's a true jewel in the winter night skies of the Northern Hemisphere. Ancient civilizations revered Sirius for its intense brightness, but modern astronomers were in for a surprise when, back in 1862, they discovered a hidden companion, Sirius B. While Sirius itself blazes visibly to the naked eye, Sirius B is 10,000 times dimmer, almost a ghost. It wasn't until the Hubble Space Telescope gathered new data in 2005 that scientists were able to accurately estimate Sirius B's mass, even though it remains incredibly difficult to observe from Earth. Now, zooming out a bit, within just 20 light-years of our Sun, there are about 131 known objects, stars, brown dwarfs, and even sub-brown dwarfs. Out of these, only 22 stars shine brightly enough to be seen without a telescope, that is, with an apparent magnitude of 6.5 or better, the faintest visible limit to the human eye. Among the 131 known objects, 103 are main sequence stars, 23 of them are heavier stars, and a whopping 80 are red dwarfs. Scientists have also spotted 21 brown dwarfs, one sub-brown dwarf, named Y0855-0714, possibly a rogue planet, and 6 white dwarfs, the quiet remnants of stars that have used up all their hydrogen fuel. There was a moment in cosmic history when Scholz's star, a small red dwarf and its brown dwarf companion, passed by the very edge of our solar system's Oort cloud around 70,000 years ago. Right now, it's about 22 light-years away, but back then, it probably stirred up a storm of comets that, even now, are slowly making their way toward the inner solar system. It'll take them over 1,000,000 years to get here. Other stars, like the G-type star HD 7977, also had close encounters with our solar system, passing near us around 2.8 million years ago. Today, it's about 247 light-years away. And these close encounters aren't just a thing of the past. Our future will be full of them too. Over the next 15 million years, about 694 stars are predicted to approach within 516 light-years of the Sun. Of these, 26 stars might pass within 3.3 light-years, and another 7 stars could come as close as 6 light-years. But this is likely just scratching the surface. There are probably many more we haven't found yet. One star stands out among these future travelers, Gliese 710. This orange star, about 60% the size of our Sun, is barreling towards us at a breathtaking 5,499 kilometers per hour, around 32,000 miles per hour. In about 1.29 million years, Gliese 710 will pass us at just 10,520 astronomical units. That's more than 100 times the distance from the Sun to Pluto. Even though it sounds far, its gravitational influence could stir up the distant icy bodies in the Oort cloud, potentially sending showers of comets inward, lighting up the skies with around 10 comets visible to the naked eye every year. Fortunately, we don't have to worry about it disturbing Earth's orbit. Its effects should only be felt in the outer reaches of our solar system. Still, it's thrilling, and a little humbling, to imagine future skies filled with icy visitors, set loose by a star that passed by long before. As we speak, our solar system, along with nearby stars and brown dwarfs, is moving through a region called the local interstellar cloud, a relatively small area about 30 light-years wide. This cloud, in turn, lies inside the local bubble, a gigantic, oddly shaped cavity in the interstellar medium, spanning around 1,000 light-years across. Our Sun wasn't always inside this bubble. Around 14 million years ago, it was still outside. It only ventured into the local bubble about 5 million years ago. Interestingly, while stars have formed on the surface of this bubble, none have formed inside it. Today, because of the protection offered by the local bubble, and the quieter, more stable conditions it provides, life on Earth has been able to thrive. It's a reminder of how even the largest, most cosmic events play a role in the delicate balance that makes our existence possible.